Namaskar मित्रांनो. Like series resonance, we are having parallel resonance also. So in parallel resonance, we have to consider the circuit, which is a combination of RL in series, and the series combination is connected in parallel with capacitor. The current coming from the supply is I. So at resonance we write it as a IR. Okay, this current will get splitted into two parts. One is flowing in this coil, that is combination of R and L, and one current, that is IC, is flowing in capacitor. Now this total current, therefore we can write as IR bar is equal to IL plus IC bar. Okay, so this is there. But now this IL will get splitted into two parts. One is resistive part and one is inductive part. So this resistive part is nothing but the resolution of that IL as a IL cos phi, and this inductive part is nothing but IL sin phi. Okay, so IL cos phi. This IL can be splitted into two parts. One is resistive part is given by IL cos phi, and second part is inductive part IL sin phi. Now what is the condition for resonance here? For condition like in series, we are having condition that supply voltage must be equal to resistive voltage. So here also supply current must be equal to what? Resistive part of the current. So here if I draw the phasor diagram, first of all I will complete for this coil. Coil साठी काय? Resistive part will be on x axis, so this is IL cos phi. Inductive part will be lagging by 90 degrees, so it is IL sin phi. So combination of these two, if I complete the triangle, I will get IL over here. Now capacitive current is 90 degree ahead of the resistive current, so I have drawn capacitive current on the positive y axis. Okay, and the resultant of this IL and IC must be IR. Now I have shown IR on the x axis because for resonance this IC must be equal to IL sin phi. So these two will get cancelled with each other. The condition is IC is equal to IL sin phi, and that's why your resonance current is must be equal to resistive current. IR is equal to IL cos phi. Okay, now this condition we will derive further to get the value of resonating frequency. So IC is equal to IL sin phi. But what is IC? It is V upon XC. Simple parallel circuit is there. So V by XC will be IC. Then what is IL? V by ZL. And what is sin phi? If I draw the phasor diagram for this choke coil, it is R and XL and ZL. And therefore if I want to write sin phi, it is opposite, that is XL by ZL. So this is the condition. Now V will get cancelled with each other. I will get 1 upon XC is equal to XL by ZL square. So what is XC? 1 upon 2 pi FRC. So I have written this here. XL is 2 pi FRL and ZL square. So I can rearrange the term because see here 2 pi and 2 pi will get cancelled. I will get ZL square is equal to L by C. But what is ZL now? It is XL square and R square. So it is equal to L by C. But if I take this R on other side, it will get L by C minus R square and 2 pi FR L square. Solving further, I will get FR is equal to 1 upon 2 pi L. हा पार्ट इकडे खाली जाईल 1 upon 2 pi आणि अंडर रूट मध्ये राहील L by C minus R square. जर मी हा L आतमध्ये घेतला तर इट विल बिकम 1 by LC आणि R square by L square. आणि जर R ची व्हॅल्यू इज व्हेरी स्मॉल, वी कॅन निग्लेक्ट दिस पार्ट सच दॅट approximately resonating frequency will become 1 upon 2 pi under root LC, which is same as series resonance. Okay, so FR is equal to 1 by 2 pi under root LC. This is an approximate value which is same as your series resonance frequency. Now how to find resonance impedance? So we have written at resonance current IR, that is supply current must be equal to IL cos phi, that is resistive part of the current. What is IR? V by ZR, that is resonance impedance, okay, and IL is V by ZL, cos phi is R by ZL. From this you will get cos phi R by ZL. So ZR, so see here again VV will get cancelled. ZR is equal to what? ZL square by R. But now we have the formula over here, ZL square is equal to L by C. That I am putting here, so that we will get ZR is equal to L by RC. That is the final expression for resonating impedance. Lastly, Q factor. Q factor is nothing but in a case of series resonance, it is a voltage ka division. Here it is current ka division. So IL or IC you can take. So IC by total current. Okay. But what is IC? 2 pi FRC into V. V upon XC. No? So 2 pi FRC into V. And what is IR? We have put this IR as V upon ZR. Okay. So ZR is L by RC, 2 pi, frequency is 1 upon 2 pi under root LC and C. So this 2 pi will get cancelled, and if I rearrange L, I will take inside the square root, so root L will get cancelled. This C and this C is getting cancelled over here. So Q factor is equal to 1 by R under root of LC. That is the final expression for Q factor. So this ends your parallel resonance. Now we will see one numerical based on series parallel impedances. Okay, that will end our single phase AC circuit after completion of that numerical. Simple numerical I am taking here. Find equivalent impedance for above circuit. This is a given circuit for which we want to find a total impedance, equivalent impedance. Why I am taking so simple numericals? Just for finding impedance. If you get the impedance, जर व्होल्टेज माहिती असेल तर तुम्ही करंट सुद्धा फाइंड करू शकता, पॉवर सुद्धा फाइंड करू शकता, सगळ्या गोष्टी फाइंड करू. बेसिक थिंग इज दॅट वी हॅव टू फाइंड द इम्पिडन्स फर्स्ट. इम्पिडन्स असेल तर आपल्याला सगळं फाइंड करता येतं. ओके, तर इथे काय आहेत आपल्या 3 ब्रांचेस आर देअर. दिस इज माय फर्स्ट ब्रांच which having R1 resistance and L1 as a inductance in parallel with the second branch R2 and C2 we can say, and this is third branch R3 and L3. So for each branch we will just find the impedance first. So branch 1 चा impedance असेल R1 plus J XL1. So आपल्याला XL1 find करायला लागेल. हे component आहेत branch 1 मधले. XL1 is 2 pi FL1. See here, though voltage is not given, frequency is given, so we can easily find XL1. So I am getting the value 6 ohm. Z1 is equal to 2 plus J6, which is equal to 6.32 at an angle 71.57. For branch 2, I am having resistance 7 ohm and capacitor 398 microfarad. So I will find XC2 as 1 upon 2 pi XC2. C I have to take in farad, so I have to multiply by 10 raised to minus 6. By solving I will get 8 ohm as the answer, and therefore Z2 bar is equal to 7 minus J8, 10.63 minus 48.81. Similarly, I can find Z3 as 12.81 at an angle 51.34. Now we need to find total Z. Total Z is nothing but what? Parallel combination of Z1 and Z2 in series with Z3. So Z1 parallel Z2 plus Z3. So we will find Z1 into Z2 divided by Z1 plus Z2 just by using the polar forms over here. For Z1 and Z2 I have not found the polar form, which is I have done here. So Z1 plus Z2 is equal to 2 plus J6 plus J7 plus 7 minus J8. So that will give me 9.22 at an angle minus 12.53. This value I will substitute over here, and by solving I finally magnitude चा काय होईल multiplication आणि 9.22 ने division. Angles will get added and subtracted. Okay, 71.57 minus 48.81 plus 12.53 gives me 35.29. पुन्हा आता Z3 बरोबर ऍड करायचे, बट पोलार फॉर्म मध्ये ऍडिशन नाही होऊ शकत. That's why I am doing or converting this polar into rectangular. And Z3 I am writing in rectangular, 8 plus J10. आणि जेव्हा केल्यानंतर 13.95 प्लस J 14.21 येत आहे. टोटल Z इज 19.91 अँगल 40.53 ओहम. Okay, this is my final answer. This is my final answer. If now see we are having all Z's. जर तुम्हाला इथे व्होल्टेज दिला असेल 230 वोल्ट काय आणि मग तुम्हाला करंट फाइंड करायचं आहे, यू कॅन जस्ट 230 डिवाइडेड बाय Z यू कॅन टेक टू गेट द करंट I. If you want to find power, if you have got I, we are having resistive part of the total impedance, so I square R करून तुम्ही पॉवर फाइंड करू शकता. जर तुम्हाला इंडिव्हिज्युअल करंट पाहिजे, टोटल करंट असेल तर तुम्ही करंट डिव्हिजन रूल वापरू शकता Z1 आणि Z2 साठी. दॅट विल गिव्ह यू करंट इन दिस अप्पर ब्रांच अँड लोअर ब्रांच. तिथे पण तुम्हाला पॉवर फाइंड करायचं तर I1 स्क्वेअर R1, I2 स्क्वेअर R2 असं करून सगळ्या पॉवर्स मिळू शकतात. So that completes total single phase AC circuit. In next video we will start with 3 phase AC circuits. Thank you.